Hello and welcome to another video in the Open Computer tutorial series for version 1.3. My name is Lord Yoda and I'm here with Sangar, the lead developer of OpenComputers, and Daka Total, our cameraman. Well, in this video we want to take a look at robots. For now we have always dealt with, stationary computers that could use components, but, we want to get in motion, so we want to use the robots.
Exactly. So earlier, in the earlier versions of OpenComputers, the robots were a simpler crafting recipe, so you just built them using a few items in the crafting table. In 1.3 this changed a lot, and now there's a new block, which is the robot assembler. And this block is used to basically configure your robots in a lot more depth than was possible before. So it has a GUI and it tells us to insert a computer case. So this is how you get started basically. So I'll pick up all the stuff I have around here and put in the computer case. And what we see then is that there are a lot of slots, and these are basically the slots of components that will be built into the robot. So to the right we have the basic stuff that's also used for normal computers, like your RAM and CPU and cards and hard drives. And to the left there are slots for upgrades, which are the upgrades from before, so stuff like a crafting upgrade, navigation upgrade, so they can basically query their location, all that stuff. And the slots below are the container slots. So these are kind of upgrades, but they are very specific in that they provide a slot for something else in the finished robot. So these are basically a way to configure GUI slots in a robot. And whatever you put in here determines what you can put in the robot. So for example, there is a upgrade container. This allows you to put in upgrades into the finished robot afterwards on the fly and exchange those. And there's a card upgrade card container, which allows the same thing for cards. And one more container type is the disk drive. This allows you to put in floppy disks on the fly. So now the next step is to put in a CPU and some RAM, and then we see that there's this complexity. So the complexity determines basically how many different types of items and what tier of items you can put into the robot. If the number in front of you exceeds the maximum value, you can't build the robot, it just won't build it. The number is computed based on the tier of the items, so a tier 1 item introduces 1 complexity, tier 2 introduces 2 complexity, tier 3, 3 complexity, and so on. Containers are the same, but they are counted twice. So a tier 1 container is 2, a tier 2 container is 4, and a tier 3 container is 6 complexity. Right, so in the top left for the upgrades, a few non-obvious ones are the screen and the keyboard. So if you want to have a robot with a terminal where you can actually input some commands, you have to build in a screen and a keyboard. Otherwise it won't have a GUI with a terminal in it and you can't insert commands. You will have to basically provide the program logic via an autorun script on a disk. So usually you want to do this. You have to use a tier 1 screen, tier 2 and tier 3 screens are not supported in robots. They are too high tier for robots. Right, so another thing, if you hover this assemble button, you will see that there's a warning. It will tell you that there are a few components missing that are recommended for robots. You can build your robot without these, but usually you will at least want to check what it tells you to make sure you didn't forget anything important. The most important thing usually being the bootable medium, so that the robot even starts up. Because if you don't insert a OS disk, you better have a disk drive as a container in here, or you won't be able to boot the robot at all. Alright, so the next thing, you probably want some inventory in your robot. Unlike before, robots now have no built-in inventory for items, so if you want to store items in the robot, have it pick up items, you have to build in an inventory upgrade. Each inventory upgrade provides 16 slots of inventory space, and a robot can have up to 64 slots of inventory space, so more than 4 inventory upgrades bring no further benefit. Let's see. I'll build in this upgrade here to demonstrate it later on. This is an upgrade that allows the robot to perform more precise operations on inventory, so to speak. Let's put in the graphics card, and just for the heck of it, these two. Alright, and then we see, okay, now we didn't reach the capacity limit, so we can still build it. And yeah, that's looking all good.
HDD maybe?
I don't think we actually need it.
Okay.
So not for this demonstration purposes, because we won't write any custom programs that need to persist. But sure, if you want to have some writable storage in your robot, you might want to install a disk drive. But for now, the operating system is enough. And we have a disk drive container in here, so we can put in a normal floppy later on if we really need it. And what happens now if I click assemble is that it starts building the robot. So we have a progress bar here, and it tells us how long it will take to finish building the robot. This is assuming that there's enough power. So it might be that it takes a little longer than whatever is displayed in the tooltip if there is not enough power to consume. But yeah. Right, so, and when it's done, you'll also notice that this bar here on the side of the block goes dark, and then it's done. And when it's done, you can collect the finished robot from the top left slot here. And what you'll also notice is that it has some stored energy in it, so unlike before, the robots now start with the base energy, which is basically charged into them during the assembly process, so to say. Right, so with this robot, which I can place, let's say, I don't know, right here. If I open it, I see it now. As it has a GUI, it has the slots to the bottom right here, which are the container slots I installed, so the upgrade container, the card container, and the disk drive. So I can put in an upgrade, a card, and a floppy disk. And it has an inventory of 16 slots. So if I had more inventory slots, if I had 2 inventory upgrades, I could scroll in this GUI. But I only put in 1, so I can't. Right. So what can you do with the robots? Well, for one, you can turn them on and then program them like normal computers. So they behave basically the same as the computers do. So they have a shell and they have the built-in programs and all of that. What they have in particular, though, is this slot to the left here. This is the tool slot. This is basically what the active slot of a player's hotbar is. So whatever is in here is the robot's equipped tool, and can use these tools in most cases pretty much the same way as a player can. So if I give it a pickaxe, for example, and put a stone block in front of it, I can now tell it to break this block by telling it to swing its tool. So I say robot.swing, and the block is gone, and it has the collected block in its inventory. What I can also do is tell it to place blocks it has in its inventory back into the world. So place is basically, well, it places a block from the inventory. You can also place blocks in the tool slot. That's a bit different. I'll show that right after this. So if I say place, it places the block back down in front of it. Let's see. The normal place swing methods, these are for in front of the robot. There's also a variant for above and for below the robot, which are just called swing up and swing down, the same way for place up and place down and whatever else methods there are. So if I put the cobblestone block into the tool slot of the robot now, what I can do now is say robot.use, which is basically a right click, and this is essentially the same as place, but it works on the tool slot of the robot. So in simple terms, swing is basically a player's left click and use is a player's right click. Let's see, so if I remove this block again, you'll notice now that the pickaxe took some damage. So tools used by robots are also subject to item damage. However, they take damage a little slower than if used by players. So per default, I'm not exactly sure what the values are, but they have a certain chance to take damage instead of always take damage. There are also ways to manipulate this a bit. So there's, for example, the experience upgrade, which will allow robots to be even more efficient with their tools. Okay, so what we see in the inventory here is this green circling frame around the first slot. This basically means that this slot is selected, so a lot of commands of the robot operate on the selected slot, such as place. There are also commands for manipulating inventories, which I will show now. So if there's a chest in front of the robot, it can put items into the chest and suck items from the chest, and this also takes into account the selected slots. So if I say robot.drop, it will place the selected item into the inventory in front of it, if there is an inventory. So in this case there's a chest, and it put in the cobblestone. If there were no chest, it would just drop the item into the world. The same is for robot.suck. It will take the item from the chest, and this will also look at the selected inventory slots. So if I go ahead and say I want to select the 16th slot, so the last one, and then I say robot.suck, it will place the item into the selected slot instead of the first one. So that's that. Now, one upgrade I put into the robot earlier was the inventory controller upgrade. So this one. This allows robots to control into which slots specifically they want to insert items into inventories and to pull them from. This can be useful for machines, for example. So if you have specific slots in your machines where items have to go into for them to work, you can specify to put the item in the nth slot, for example. So if I go ahead and say component controller drop into slot, and let's see, is it on screen? I don't think it is. Okay, so components, controller. Is this in here? No, it's sorted. Oh, well, let's do this then. Component inventory controller.
There is an inventory.
No?
You wrote inventory.
Oh, I did. Close enough. Right. So the drop into slot method takes the side of the inventory. So unlike the built-in robot.drop and suck methods, which have alternatives of robot.drop up, drop down, and suck up, suck down, that's not the case for the inventory controller. You have to specify the side of the inventory directly as a parameter. So let's say we want to interact with the inventory in front of us, so that's sides.front, and then we want to put it into slot 5. And there goes the cobblestone, and we see it's in the 5th slot of the chest. And the same works for suck from slot, of course. One more thing that the inventory controller upgrades provides is the equip method. This allows the robot to swap out items in its tool slot. So if I say robot select the second slot, and then I say inventory controller equip, it will equip the item in the selected slot, inventory slot, and put it into the tool slot. If there is some item in the tool slot already, it will just swap the items. So if I take the 6th one and call equip, then it will just flip the items, as we just saw. Right. So that's basically how you interact with inventories. One final thing, if I tell the robot to turn around. So this is how you tell the robot to change its facing, and you can also, well, of course, make your robot move, so you can tell it to go up and to go down and forward and back. That's simple enough. So if you want to make it move somewhere, just call this often enough. And it will also, well, maybe this is more interesting. If I tell it to go down now, it will say, nope, this doesn't work, and it will also return what the cause for the failure of movement was. So in this case, there's some solid object below it. If I tell it to go, let's say, back, and I stand in its way, whoops, it'll tell me there was some entity in the way. So this allows you to basically have some more information about what hindered the robot from moving if you need it. Right, so if I now place this piston and move up one, whoops, I can demonstrate one final feature, and that's that robots can also, whoops, oh, can't I place, wait. Is this... oh no, wait, no. Why do you do this to me? Anyway, let's go some forward. And then place down. This will work. Right. Is that robots can interact with blocks, they can activate blocks. So for example, they can activate levers. So if I say robot.use down, oops, it'll flip the lever and the lever will trigger the piston. So that's the other thing. So yeah, you can press buttons with robots. Like I said, you can make the robot use most items like a player. So, for example, more examples of items that can be used are bows, so they can shoot arrows if you want them to, and stuff like that. So just play around a bit. For the most cases, it works the same way as for players. So use is right click, swing is left click, and it will usually just work. In some cases, it also will work for the place stuff. So for example, seeds can be placed, bone meal can also be placed, I think. So you can use bone meal via the place method, I believe. But usually if it doesn't work with place, just try it with use first. Right. And that's the basics. What else could we show about robots? Anything? Ideas?
No.
Nope. Good. Nah, I think that covers the basics of it anyway. So, well, it's worth mentioning. So, as you saw, you can place cards in robots. So you can do wireless networking with robots, for example, to remote control your robots. You can trigger redstone signals with robots. So you can put in a redstone card. That also works. Most things work the same with robots. The only thing that's important to remember is that robots cannot interact with external block components. So, for example, you can't use a motion sensor with a robot, or you can't use a Redstone I/O block with a robot. You can't control screens from a robot and stuff like that. So they're pretty much isolated into themselves. So that's the main intentional limitation of robots.
What we could do is show the upgrades you can use. So
and just mention
maybe
them.
Okay. For example, the shield, the sign upgrade, and so on. I mean, just for
just to go through them. Sure. So there's a couple of maybe can I filter by upgrade? That would be nice. Yes, I can. Great. Right. So these are the containers, we don't care. Let's see, where do we start? So the basic one, for example, there's a sign I/O upgrade. You can modify the text on signs with that and read the text on signs. You can have a crafting upgrade. With this, you can make the robot craft items like players do in a crafting table. So basically, you just have to arrange the items in the inventory of the robot accordingly to the recipe, and then call the craft method on this upgrade, and it will try to craft the item. and put it back into the inventory of the robot. The Angel upgrade is used to allow robots to place blocks in thin air, so without reference block. So for example, if this robot would try to place a block on top of it now, that wouldn't work because it has no place of reference. So the same way as players cannot place blocks in thin air, this also applies to robots, but with that upgrade you can do that. The battery upgrades, well, they just provide some more power capacity to be stored inside of the robot, so what you see here, the energy level. So this is the internal energy storage of the robot before they have to go back to a charger. And oh right, chargers, we didn't mention chargers. That may be important. So the charger block is what's used to recharge your robots. So you see it has an energy bar here, that's the internal energy storage, and when that reaches 0 it will turn off because it has no more power. And to recharge them you have to place them next to a charger block, and these, when connected to power, will recharge robots next to them on any side of them. So yeah, chargers, important. Right, and the battery upgrades just increase the capacity of energy they store, so they can run around longer without returning to base. The Chunkloader upgrade, well, you might guess what that does. It loads the chunk of the robot, so you can have it run around in the world without players being nearby or other mods chunkloaders. The experience upgrade, this is a bit more complex. So this is an upgrade that allows robots to basically gather experience by doing stuff like breaking blocks, mostly by breaking ores. That gives more experience usually, so like coal and stuff, so ores that also give the player experience. A little bit even by just walking around. And they gather experience pretty slowly, but they can reach up to level 30. And for each level they gain a bit more internal energy storage, so they basically act like a levelable battery upgrade, and they also get better at using tools, so the durability doesn't decrease as fast as usually, and they also get faster at using them, so the cooldown after using a tool to break a block gets decreased a bit. The generator upgrade allows the robot to refill its buffer basically by burning some fuel. So this is for solid fuel like coal and charcoal and stuff like that. You can insert that using an API method. So there's, I think it's component.generator.insert, and that will insert an item from the inventory, from the selected inventory slot, into the generator if it's a usable fuel item, and then burn it for energy. The inventory upgrade, as mentioned, it provides inventory slots for the robot, so if you don't have that, it doesn't have an inventory, so these will be unusable. And for example, if the robot breaks blocks, it will just drop the blocks into the world, it cannot pick them up. The inventory controller upgrade is what we just demonstrated, so it's the one that allows the robots to control into which slots to drop items and from which slots to suck items, and to change their equipped tool. The navigation upgrade allows robots to get an idea of where they are relative to a fixed position. So these are crafted using maps. So the map used for crafting these determines where the point of reference for this upgrade is. So let's say a map is centered at 0, 0, just for simplicity, then all coordinates will be relative to 0, 0. And the tier of the map also determines the range of this upgrade. So if the map has a small radius and the robot gets out of that radius, then it will no longer be able to tell its actual location. It will just be able to tell its facing. And you can recraft these, so if you want to basically relocate, you can just craft a navigation upgrade together with another map to use that map as a new center, and it will give you back the old map that was used to craft the upgrade. Right, so we already had it. The solar generator upgrade is, well, just a passive way of generating some energy. It's not very efficient, but it works passively and all the time as long as there's sun shining onto the robot. So it won't work underground and it won't work when it rains, but if the sun is shining it will work. And lastly there's the tractor beam upgrade, which is basically just an item magnet. So it allows robots to pick up items from within a certain radius around them. So not just as usually from before, above or below them, but in a radius of, I think, 3 blocks around the robot. Any item lying around in that radius can be picked up using this upgrade. And that's all upgrades that are built in for now, I think. Yes.
Yeah, of course, there might be more upgrades coming.
Indeed.
Yeah.
And there are also already a couple of add-on upgrades, so if you check the forums, there are a bunch of upgrades that can also be used. For example, Computronics adds a lot of neat upgrades like cameras and stuff like that.
Yeah, right. So, we hope we could give you a nice impression about how to build your robot and how to operate it. So have fun with it, and thank you very much for watching. And yeah, I think that concludes our tutorial series. We hope you enjoyed it, you learned a lot, and now impress us with your creations. Right. So, any last words?
Nope.
From the
Not
cameraman?
really.
Oh, no. Yeah,
If anything breaks, tell me, but other than that... Oh, well,
yeah.
Wait. No, that's important.
Yeah, so as we often mentioned, please keep in mind this video was made with the version 1.3. So if you watch this at a later time, that when maybe 1.4 or I don't know which version is already out, there might be some changes. So yeah, take a look at the changelog, and if this still doesn't help, maybe we have created a new video, then take a look at that. And yeah, so I don't know if there is still some
Any
problems.
questions?
Yeah.
Well, if you have any more questions, sure, just go to the forums and ask them there. If you think there's some topic we oversaw and should have made a video about, tell us, and we might just make a video about it. I don't know.
Yep. Right.
But other than that, I think
And
that's
if you
pretty
found
much the
bugs
basics.
and crashes, well, they are also bugs, but yeah,
Keep
you
them.
know what I mean. Don't show us! Don't show! No,
I don't want to know.
Please go to GitHub and report them there, and yeah, please also include your crash log, because otherwise we can't
please,
do-
the exact version of OpenComputers you used and crash logs and everything, yes.
Right.
Otherwise, it will just take longer.
All right. So now I think we finally reached the end.
The end
So-
is near.
We're gonna die. So thank you very much again for watching, and until next time. Bye.
Bye-bye.